Okay, Marquis, you can go ahead, man. Mm-hmm. All right, that's 20 points, sir. Thank you. Notice, I helped you out. I put the symbol already in there this time around. So you can literally, if you don't want to go to the your special character set, you can copy those symbols wherever you need them. Just saying. And that's how it's supposed to look. So, as same is true for your R1, R sub 1s, R sub 2s, that's how you write it. Like I put it in a problem. Right? Just copy how it's written into your notes section. So before I do all that, you need two parts to your notes, right? First is our old friend, Ohm's Law. You'll probably be tired of hearing Ohm's Law by the time summer school's over, I swear. You go to page, see, I think it was 750? What was that? Yeah, I was right. Ooh, I got this book memorized. 751, Ohm's Law, that green box. We did this yesterday. If you did it yesterday, you can use it today. The green box at the top of 751 is the first part of your notes. Please put it down, or go to yesterday's document and put what you put down for this green box, right? You should be typing everything in that box down, and I'll tell you what the second equation is, and we're going to do the problem. 751 at the top is a green box. It says Ohm's Law. Yep. All right, so Ohm's Law, what is it again? We saw it in our simulation. V is equal to I times R, right? Remember, the other way to write it is, I'm not going to put or there, because I had to write something else there. Another version is when you're dealing with electromotive force, and that's epsilon. All right, and I've been looking at some of the assignments. I got to put epsilon every time you see that weird 3-looking E thing. It's not that. It's called epsilon. It's a Greek letter. If you need help finding it, I'll show you. So it looks like this. You can also look in the book to see it when we do the problem. I total, and it's multiplied by R sub EQ. Remember, you're talking about your voltages. They are measured in terms of volts, whether you see V or epsilon. Your currents, whether you're talking about I total or individual I, I1, I2, I3, whatever, it's amps. Okay? And then lastly, we talk about our resistances, REQ, or just R sub 1, R sub 2, so on and so forth. It's omega or ohms. Okay? Again, this character here is known as epsilon. So if you're looking for it in your special character insert, that's the name of it. So you can find it and use it. If you put it in there once, you can copy paste it everywhere else you need it. So we want to do that right now. All right, anyway, this is found, so you get all the credit for this first part of your notes on page, again, at the top of the page, 751. Please put everything in that box and explains it. So, what? There's an outlet over there, I guess. Or you know what you can do. Dude, look, I gotta finish teaching. I can't step out. Jaden, what I was gonna say is you might want to sit at one of these desks because they have outlets on the side and they connect to these poles. So you can you have to move over and just plug it up. You see the outlets on the side there? No. Okay. So those are those tables, they have electricity going through them. You just plug in and you should be good. I'm gonna do this part and then Martinez, I'll walk out. Right? What's wrong, man? You sound like you fighting the computer. All right, part 2 of your notes. You gotta go to a different page for this, right? Remember I told you there's a different equation. It has fractions and stuff. That's equivalent resistance for parallel circuits or parallel resistors, right? So the next equation box is on page 760, right? And the problem, if you ever wanted to figure out and you forgot, it's right here. It's called 3 resistors in parallel. This thing is a problem right here. Now, you need this green box, type it up, just like I'm about to write it out, and it's found on page 760. That's the next equation you need. The name of this equation is equivalent resistance for resistors in parallel, okay? Let's keep that in mind. So what does that equation look like mathematically? Again, on page 760, it's everybody's, most people's favorite nightmare. I can't say favorite, but most people don't like fractions, is what I'm trying to say. So it's, use parentheses if you know how to type this. It's 1 over R cubed, right? Is equal to 1 over R sub 1. Use your subscripting, y'all. These are subscripts. Plus 1 over R sub 2 plus 1 over R sub 3. Okay? And then the plus dot 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 in the box just means if you got more resistors. Like R4, 5, 6, right? Again, you don't have to draw the arrows and stuff. You just type what's in the box for this one on page 760. 760. We talk about resistors that are in fraction mode. They're all measured in terms of, let me just do this like this. We got omega to the negative 1 or ohms, and that's going to be raised to negative 1. That's important because when we do this problem, you're going to be like, what's that right there? And then you're still not done because you got to flip the fraction, right? Because it's 1 over. That's why it's to the negative 1. To get credit for all this, just write what's in the box. Again, I keep saying, on page 760, and you'll get credit for your second part of your notes. That's in the book. All right. Now the real main event is doing the known unknowns and the problem. It's a long problem. So let me do it as fast as I can because it's 12:35 and I know they're gonna get y'all in 10 minutes. All right, and I'll post a picture if y'all run out of time, so don't panic. You are responsible to finish it all. So number 3, let's write down or grab the ingredients we have in this problem. So look at the problem. It states that you have R sub 1, and that's equal to 243.67 omega. R sub, are you okay with that? Okay, R sub 2, we got 197.71 omega. R sub 3, we have 399.28 omega. And last but not least, epsilon, that's not a 3, y'all, or E, epsilon, that's our voltage, or electromotive force, is 31.43 volts, all right? We have to find the total current. We also have to find all the individual currents like you see on this screen here. Now, the currents are the same because the resistors are the same, but in most cases, like you see, the voltages have remained the same, right? After we fix it, of course. Now, if I had different resistors on there, there'll be different currents. But in most cases, the currents will change. The voltage will stay the same in parallel circuits. So, 2 parts of this problem. What do we know, right? I mean, what are we gonna ask? We know what we know. We got the ingredients. So we need I total. So some number in amps. We need I sub, and this is part A, right? For part B, we need I sub 1, some number in amps. We need I sub 2, which is also some number in amps. And I sub 3, because you got 3 resistors, some number to calculate in amps. Let's box this off. And part 3, we begin our quest for solving this problem. Part A is the biggest part. Part B falls apart easily after you figure out A. So let's do it. Like night, just do it, right? So, part 4 of your notes, you're going to say, hey, in part A, beginning part A, I would say, you want to solve for I total. Okay? To do that, actually, I'm moving too fast. You're going to solve for REQ to get I total. So we have equivalent resistance, right? That's what we saw before. We got to use this equation here first. And then we come back and get I total using our algebra skills. But let's go ahead and do REQ, because that's a calculation you got to make. And there's a special technique you got to use too. All right. Sound like Wu-Tang, special technique of shadow boxing, something like that. So let's do it. 1 over REQ is equivalent to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3, right? Now plug in your numbers, okay? So let's go ahead and do that. This is one of your iterations. If you did it here, then you can just copy paste it again, right here, right? That's it, you did it in that green box, right? Coming down, we plug in our values. So 1 over REQ is equal to the bottom. So this is R1, 243.67 omega. Okay. And 1's on top of it. We got R2. All right. And also R3 is on the bottom of this one. So now we calculate. You use the calculator's fraction mode to make that easy on you. So what do? I grab my calculator. And if you're not sure on these newer calculators, it's easier, just hit the fraction button, which is right here next to this book or whatever. And I can make a bunch of fractions. So I can hit fraction, 1, come downstairs. That is 243, 67, plus, make another fraction. That's 1 over, downstairs, 197.71, come over, plus, make a fraction. 1 over 399.28. I get a yield of 0.0, I want to say 117. But that's not our actual ohmage. That's 1 over omega, right? So we got to change it. We got to calculate further. Here's how you do it. Since it's 1 over REQ, it's omega raised to negative 1. All right? So y'all can be like, what is your idea? That's not the REQ though. That's 1 over REQ. So we got to do a special math technique where we flip or do the reciprocal, right? Inverse of a fraction. To do that, just write it again. And you got a quiz on Friday, so I hope y'all are trying this out in your you do section so you don't be like trying to figure it out on the test. That's not cool. That is the quickest way to fail. Just trying to figure out the day of. Practice it way beforehand. All right, now how do I fix this? Well, I just raise everything to the negative 1 and it should flip the fraction. What you do to one side, you gotta do to the other. It's an algebra rule. All right? And then I'm gonna do the same thing to this. That allows me to flip the 1 over REQ to REQ and then calculate the real value of our equivalent resistance. So let's do that. So I'm gonna take my calculator, type in 0.0117. I'm going to raise it to the power, right? So caret negative 1, and it turns into 85.47. Now I can officially call it ohms and not ohms to the negative 1. Let's go ahead and write that. Okay, that helps us out. Now we can go ahead and figure out what I total is using our old friend Ohm's law here, using our skills. So we're almost through with the problem. I'm doing good. It's 42. We got time to finish this thing off. So we would call this part 5 of your notes. And here you're really saying, hey, in part A, we're going to continue by solving for whoever's got some hip hop music playing, turn it off. That total. That's why we can't get no work done. We have to listen to music. This music class, y'all. Or the engineering class. All right, so now rewrite the equation for epsilon and get I total by itself using your algebra. So that is the equation that we're using here is epsilon is equal to I total multiplied by your REQ that we just figured out. Write it again. All right, and then we want to separate REQ off of I total using our algebra skills. Yes, ma'am. So I will put a picture in SB. I'll finish it off, but you're required to do all parts, including part B, y'all. So look at that picture when you get a chance. Start finishing up. REQ. Cross them out. And now I can rewrite it and put the numbers in and get that done. And then I'll put part B right there. You got 6 parts to your notes. Russian. Marquis, you got 50 points because it's going to be a long problem. I know y'all going to probably leave, but make sure you add your points in for the recording because I think you got that one right. You have red and you said you take the recording points too. Okay, so now that equation works for me. I can actually get my I total now. Which is, what's the value? Let me do this because I'm running out of room. So the next part of this, it continues over here. It's going to be that total is equal to our voltage divided by our REQ. Calculate. And again, I'll take a picture of it. Is she saying line up or no? Hold on, y'all. Don't wait till she comes to the door. Hold on, Tanya. Hold on. You gotta wait for Miss Hawkins, y'all. Slow down. She's slowing up. Y'all heard her voice and started leaving. I'm like, it's not at work, y'all. Anyway, what was the answer here? What did I get? Oh, that's what it was. Almost through, not through yet. Okay, So that's all she wrote for that step. The last step is about to be done. And it's part 6 to your notes. You need to solve, we call it part B. You need to solve for I1, I2, and I sub 3, right? To do so, we're going to use Ohm's law yet again, but a different way. All right, y'all. Y'all heard her. See you later. I'll post a picture. You're responsible for all parts. See y'all later. Go home. Be safe out there. Ooh, my arm. Look at this. I got to do.